Let's look a little bit at this hex system and why it's so handy as a shorthand to write down binary numbers. Computers don't store hex, but you will see hex written down in many, many computer texts and in diagrams because it's just a neat, easier shorthand way. So if we were to make a table, and this is in the notes, so I won't write it out completely, but the pattern is pretty obvious. Then 0 equals 0 equals 4 digits, 0, 0, 0, 0. 1 equals 1 equals 0, 0, 0, 1. All pretty boring, so let's skip ahead a bit and write down 10. 10 is A, because we ran out of the last digit for binary at 9. And that would be 4 plus 2, which I think looks like that. And 11, which is B, looks like 4 plus, sorry, not 4, 8. 8 plus 3. Up here at 15, which is the largest hex number we can represent, because it goes 0 to 15. There's that many digits. That must be F, the last hex digit, and that's 8 plus 4 plus 2 plus 1. So the point is, you can take any chunks of these, or nibbles as they're sometimes called, half of a byte, and you can simply translate them one-to-one into hex digits. Let's apply this and see how we can take 8-digit binary numbers, usually called a byte, divide them into 2 4-digit numbers, 2 nibbles, and write those as 2 hex digits. That's just a convenient thing to do. So what if we had the binary number 0, 1, 0, 0, and I'll put a comma here, just so it'll help us visually separate this, and 1, 1, 1, 0. Now this represents 8 binary digits. We'd translate those with this being the 2 to the 7th place. But right now, we want to first go through hex. Well, that's 4, right? 0th place, 1's place, 2's place, 4th place. Yeah, that's 4. And this is 8 plus 4 plus 2, which sounds like 14, which is E. So that's what the number looks like when written in hex. It represents these 8 digits, but we've taken 2 hex chunks and written them that way. And then finally, we could translate this to decimal. We'd have E, which is 14. That's that part of the number. And we'd have 4 times 16, because this is the 16's place in the hex number. So this is 4 times 16. And look at my notes to cheat. That is 78 base 10. So this is just an easier thing to manipulate. Let's do another one. Examples are good. 1, 0, 1, 1, 0, 1, 0. Let's do 1, 0, 1, 1 in the first nibble, and 0, 0, 1, 0 in the second one. So this is 8 plus 2 is 10, plus 1 more is 11. Oh, we wrote that one down. That's B. How nice. And that looks like 2. All right, not so bad. Therefore, this is 11B times 16, because this is the 16's place of this 2-digit hex number, plus 2 times 16 to the 0, which is 2. And that is 178. So hopefully that gets you the idea of why B2 is an easier thing to write than 1, 0, 1, 1, 0, 0, 0, 1, 0. It's just a more convenient notation, and it's a more compact notation when using 8-digit binary numbers.